Now, we have seen a basic example for defining random variables. And as I said, you define a random variable as you see it useful. So the definition will depend on you to construct your mathematical model. And here, let's say you have 3 coins. And essentially, you have 8 possible distinct outcomes. You have heads, 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 or you have heads, heads, tails, or you have heads, tails, heads, and so on. If you care about the order, you will have to distinguish between all of these. So the simplest thing you can do here is a direct enumeration. To heads, 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 you assign 0. To heads, heads, tails, you assign 1. Heads, tails, heads, you assign 2, and so on. In fact, this is a binary assignment. For instance, if you assign heads to 0 and tails to 1, the 3 coin tosses is going to define a binary number, a 3-bit binary number, whose value gives this random variable here. But this is one possible definition. This doesn't have to be the unique representation of this random experiment. For instance, you can define another random variable, let's say y2, where you assign the value of 0 to this outcome. You assign 1 to these 3. You assign 2 to these 3, this one, and this one. And finally, you assign 3 to this. Okay? So how did we define this? These numbers are not selected randomly. They mean something, and it's the number of tails in each outcome. Here you see, I don't have any tails here, so it's 0. Here I have just the 1. Here I have, again, 1. And this, I have 2. So it's mapped to 2. So the random variable y2 has a meaning. It has an underlying meaning. It represents the number of tails. Now, if you want to distinguish between each possible outcome regarding their order, you might prefer y1. But if you want to just work with the number of tails, if that's the only piece of information you're interested and your events are defined in terms of the number of tails, then you don't need y1. You can just use y2. But again, there exists a function which maps y1 to y2, right? So you can define a function that transforms one random variable into another. We are not going to talk about that right now, but we will see in due course in this course that you can transform one random variable into another. Now, yet another one is y3, which represents the first position heads appear. Okay, so for instance, heads occur in the first trial, so this has 1. Similarly, you have heads here, heads here, heads here, so these are all 1s. But here the first one is tails, and the second one is heads. So this is 2. This is also 2. This one has 3. Now this has no heads in it, so by convention, which means by my selection, I assign a 0 to it. Okay, you can define this in a different way. That's completely your choice. These are all mappings, and as long as it fits the mathematical definition, it's a legitimate random variable. Let's see another one, y4. And this represents the length of the longest sequence that has the same outcome. For instance, here I have heads, 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 a sequence of 3 heads, so I have 3. Here I have heads, heads. This is different. So I have a sequence of 2 heads. So this is 2. Here I have heads, tails, heads. I have a sequence of just 1 because they alternate. So this is 1. Here I have heads and tails, tails. So these 2 form a sequence of 2. So I let this to be mapped to the value 2. Again, here I have a sequence of 2. It's mapped to 2. And these are all distinct, so 1. And here I have a sequence of 2. And this I have 3 tails. So this is mapped to 3. Now, maybe you are interested in this piece of information, the length of the longest sequence that has the same outcomes. In which case you can define, instead of y1 through y3, you can work with y4. Okay, let's see a final example. Y5, let's say this represents the number of changes in your 3 outcomes. Here I have heads, no changes, so 0. Heads to heads, no change. Heads to tails, there's a change, so 1 change. Heads to tails, tails to heads, you have 2 changes. Okay, heads to tails, just 1 change from heads to tails, so 1. Here I have 1 change here I have 2 changes. Okay, here I have, not here, but here I have a change, so this is 1. And here, all tails, so no change, therefore 0. Okay, so the message here is you can define your random variable however you like, but the bottom line is you want to define it in such a way that it will help you formulate your probability in a simple way so that you can reach the probability value that you want to find. Okay, mathematically speaking, a random variable is a function, it's a mapping, and it depends on your choice, however you want to define it. Okay, but again, let me emphasize this point. You would like to define the random variable in such a way that it will be meaningful in your specific problem.